In this video, we are learning about Dalton's atomic theory. A Greek philosopher named Democritus was the first one to say that matter is made up of atoms. But atom was placed on a solid foothold as a fundamental chemical object by John Dalton. The theory proposed by John Dalton has a few postulates, and most of them have been disproved now because of the discoveries that have been made in these 2 centuries. Most of the points have been disproved, but still it is a very, very important theory because it's our first atomic theory. So the first postulate of this theory is all matter is made up of very tiny particles, which are called as atoms. Now, when you say all matter, it refers to everything. It refers to elements, it refers to compounds, it can be anything. Compounds, molecules, everything is made up of atoms. Second postulate says atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Now, the second part of this postulate is related to law of conservation of mass. We have studied in the previous videos that during a chemical reaction the mass is neither getting created nor getting destroyed. That is because atoms of each element remain same on both sides of the reaction. That is at the beginning of the reaction and at the end of the reaction. Now, the first point in this has been disproved. We now know that atoms are divisible and atoms are made up of electrons, protons, and neutrons. The third point says atoms of a given element are identical in mass and chemical properties. Now, what does this mean? Say, for example, if I have carbon atoms, all carbon atoms are identical in mass. So I'm supposed to have all carbon atoms with same mass, that is 12U. And their chemical properties will be same. The way they react will be the same. But now this has been proved wrong because of the discovery of isotopes. Isotopes are atoms of same element, but they have different mass. According to John Dalton, they should be having identical mass, but in isotopes we see atoms of same element have different masses. Now let's take the same example, carbon. It is supposed to have, all atoms of carbon are supposed to have a mass of 12U, but what we see that some atoms have a mass of 12U, some have a mass of 13, and a few have a mass of 14. So these are isotopes. We will study about isotopes later in the same chapter. No, in the next chapter, structure of the atom. Okay, the next point says atoms of different elements have different masses and chemical properties. So if I have atoms of sodium, they have their set of chemical properties and they should have their own mass. So mass and chemical properties of atoms of one element will be different than mass and chemical properties of atoms of another element. So if I have sodium and hydrogen, they are atoms of different elements, so their masses and properties will be different. But again, there are few exceptions to this. There are something called as isobars. isobars. These are atoms of different elements, but their mass is same, but they have a same mass. Okay, let me write the example here. Say for example carbon, we just saw carbon atoms can have a mass of 14U. Nitrogen atoms can also have a mass of 14U. So these are atoms of two different elements, atoms of carbon and atoms of nitrogen, but they have a same mass. So this point is again proved wrong because of the discovery of isobar. The next point says atoms combine in the ratio of small whole numbers to form compounds. So when atoms combine, they combine in fixed ratio. So for the formation of water, we will have, okay, let me balance this. Okay, so we will always have two molecules of hydrogen combining with one molecule of oxygen to give two molecules of water. So atoms, if we, okay, we are talking in terms of molecules here. If we have to talk in terms of atoms, we have 4 atoms of hydrogen combining with two atoms of oxygen, which again comes down to 2:1 ratio. Okay, so atoms always combine in a small whole number ratio so that they get particular compound. And the last point says the relative number and kinds of atoms are constant in a given compound. This explains law of constant proportion, which we have learned in the previous video, law of constant proportion. Here Dalton is talking in terms of number, but in law of constant proportion we talk in terms of mass. So if we take a compound, as I said in my video of law of constant proportion, if you take a compound irrespective of the source, it will have same atoms, it will have atoms of same element, and they would have combined in a fixed mass. If the mass has to be fixed, the number of atoms need to be fixed. Say for example, if I want hydrogen and oxygen to combine to form water, they need to combine in 1:8 ratio by mass. And we get this mass only if we have same number of atoms of hydrogen and oxygen. That is, if we have two atoms